Hi everyone, today I will walk you through my data-driven investigation of Netflix mobile app experience. My analysis covered the full pipeline from raw user reviews through NLP pre-processing and exploratory analysis to a predictive sentiment classification models and closes with actionable business recommendations. So let's start with the business context. In 2022, Netflix reported losing subscribers for the first time in more than a decade. The business problem is this: if users have frustrating mobile experience, app that crash, content that won't load, payments that fail, they can't just complain, they cancel. And because mobile is the primary access point for the millions of subscribers globally, poor app quality directly threatens revenue. This translates this into an analytical problem. So I define a supervised multi-class task classification task. The key metrics I care about are Michael F1 score because it treats all three classes equally and penalizes poor performance of minority classes. And I also use accuracy as an overall performance indicator. For the dataset is from Hugging Face. Some key characteristics from my initial exploration, the rating distribution is strongly bimodal. About 1,700 reviews are 1 star and 2232 are 5 star, with the middle ratings much less represented. There are no missing values in the critical columns and the dataset is true for our task. After loading the data, I apply several cleaning steps. First, I filter English-only reviews, reducing the dataset from 5,000 to 4,000 English entries after removing duplicates and reviews shorter than 5 characters. The final clean dataset has 7028 reviews. I then created my target variables by mapping star ratings to sentiment labels. For task pre-processing, apply a 6-step MLP pipeline to each review. First, lowercasing all text. Second, removing URLs, emails, and special characters. Third, stripping punctuation and numbers. Fourth, NLTA tokenization. Fifth, storyboard removal. Five, reducing inflected word forms so crushing, crushed, and crushes will become crush. For the exploratory NLP analysis, I have 6 findings. The first one is the rating distribution. The dataset is heavily polarized. 1-star reviews are the single largest group, followed closely by 5-star reviews. And for the review length, negative reviews are substantially longer than positive ones. From the box plot, it shows clear separation in polarity scores across sentiment classes. Negative reviews cluster near 0 or slightly below, while positive review cluster around 0.5. And for the word cloud, negative reviews are dominated by words like apps, can, watch, money, account, and update. Positive reviews center on best, loved, good, and great. The top negative backgrounds are can even, don't want, doesn't work, can watch, and worst apps. The top positive are the Love Netflix, Love app, Best app, and Great app. I also categorize reviews into six complaint things. Content quality is the most frequently mentioned in negative reviews, followed by login account issues. Then I also deal with the feature engineering. To convert text into numerical features, I use TF-IDF vectorization. So after the feature engineering, I train three models. The first one is the logistic regression. It's fast, interpretable, handles multi-class problems natively. And the second one is multinomial naive Bayes. It is the classic probabilities test baseline. And the third one is the random forest. It is an example method that captures nonlinear feature interactions. Then let's look at the model evaluation. The random forest has the highest row accuracy at about 77%, and the logistic regression has an accuracy about 74%. It has the highest micro F1 score of about 0.578. So I finally select logistic regression as the best model because it achieved the highest micro F1 and also it is interpretable and generalized well. The confusion metric confirms most misclassifications occurs around the neutral classes, while negative and positive are predicted accurately. The learning curve shows training and course validation scores converging, confirming the model generalized well without overfitting. So finally, I have some business insights and recommendations. First, content dissatisfa- content content dissatisfaction is the top issue, not just technical bugs. Second, login payment and account frictions are significant truck drivers. Third, buffering and loading failures signal infrastructure gaps. Fourth, deploy a real-time trunk risk scoring system. Fifth, monitor sentiment volume after every app update. For the future improvements, two clear next steps will meaningfully improve this model. Replacing TF-IDF with pre-trained sentence embeddings such as BERT would capture meaning that bags of birds misses, and glading more neutral class reviews or applying oversampling techniques like SMOT could significantly improve performance on that ambiguous class. In summary, this analysis demonstrates that NLP applied to App Store reviews is a powerful, cost-effective tool for understanding customer experience at scale. So, thank you for watching.